Hello, my name is Saja Hamdan, and I will be doing my honors option on two forms of non-biodegradable plastic, one being high-density polyethylene and the other being low-density polyethylenes. Beginning, non-biodegradable means unable to break a polymer in a natural way that entails that it is not safe for the environment if not recycled correctly. One common misunderstanding is the difference between non-biodegradable and recyclable. Things that are non-biodegradable, such as plastic, can be recycled and become reusable material. If not recycled, then this material will become an issue to the environment. The reason many companies use non-biodegradable plastic is because it is much cheaper than any alternative, such as glass, paper, or even biodegradable plastic. Almost always, non-biodegradable plastic is made from petroleum, a product of millions of years of organisms that have decayed. However, after this, petroleum is manufactured and is unable to break down what was once its organic matter. Before knowing what and how these types of non-biodegradable plastic are, we must understand how the polymerization of the non-biodegradable plastic is made. Seen in this slide is the mechanism of the polymerization of catalyst Ziegler-Natta, which is later discussed in the synthesis of HDPE. Beginning, there is a breakage of bonds between the chlorine and the titanium, and the formation of bonds with the R' group and the alkyl group. The active catalyst can bond the main molecules of H2C double bonded with CHR in the resonance form, making the new bond between the carbon and the titanium. H2C double bonded with HC will continue to bond with titanium till the desired form occurs, either LDPE or HDPE. They will be differentiated on the types of technology, melting, and pressure that is being used to make them. The reason that this can happen is because ethylene double bond consists of a strong S bond and a weak P bond. When the ethylene is polymerized, the weak P bond is destroyed in the process and a long CH2 chain is produced. This also explains why LDPE can make those branched chains. When polymerization occurs with the correct display of low density, the chain of LDPE can be made, which overall produces the packing of this chain. High-density polyethylene, or HDPE, its molecular structure is described as a linear long chain of carbon and hydrogen atoms, as can be seen in this slide. Because of its specific structure, its long chain can be tightly packed together and give the polyethylene a strong intermolecular force, as well as a density ranging from 930 to 970 kilograms per meter cubed, and can withstand a heat range from 248 to 356 degrees Fahrenheit. With these strong intermolecular forces, HDPE is adamant and tough to break. An example of HDPE includes wood plastic composite, plastic surgery, and food and water containers. In comparison, low-density polyethylene, or LDPE, though has the same long chain of carbon and hydrogen atoms, differs in the fact that it is highly branched, as seen in this slide. Each branch attached to the chain prevents the stacking and reduces intermolecular forces. Because of the branching of LDPE, the density is between 910 to 940 kilograms per meter cube and can withstand a heat range from 221 to 239 degrees Fahrenheit. This low density and low heat range can be explained from the difference in long and short branches on the structure. Because of this branching, LDPE cannot have a crystalline form because the branching denies the chain from packing tightly together. HDPE is found everywhere in the world because of the different properties that it can be used for. This substance is easily meltable and moldable and takes form as a hard plastic. This hard plastic can be used for a variety of different applications, such as piping, food storage, and plastic lumber. Its high melting point makes the plastic remain stiff until it hits the highest temperature it needs to melt. Shockingly, it is easily recyclable and can limit the amount of non-biodegradable plastic polymers in dumping grounds. Also, because of its resistant ability to reduce molding and rotting, making it useful for underground work such as piping. With such a high melting point, it can be very useful for everyday use such as heating food. Though LDPE is a different form of this non-biodegradable plastic, it is just as useful in everyday life. It is most known for its soft and more flexible plastic with a lower tensile strength. It has high conductibility and allows more range for the product to form because it is flexible. This substance can be most found in bottles, bowls, plastic bags, and plastic wrap. It is resistant to chemicals, waterproof, and craft resistant. HDPE is produced by 3 types of processes, all operating at a low pressure between 10 and 90 atm. The presence of at least one catalyst in each of these processes. Within HDPE, there are 2 types of catalyst, one being the Ziegler-Natta using aluminum alkyl titanium, as can be seen in slide 3, or the Phillips type catalyst, which can be used with chromium. The catalysts are being used in this case because with them present in the reaction, it will speed up the rate of the chemical reaction of the polymerization. It can help with both toxicity and the odor of the reaction. The initiator in these cases is the process of mixing ethyl with hydrogen because it can act as a single molecule that will form the intermediate compound of the large amount of monomers to form into polymers. The first type of process is the gas phase process, which begins with a mixture of ethene and hydrogen being passed over the Phillips catalyst. The ethene polymerizes into grains and suspends flowing gases. The HDPE comes out of the reactor where the gas is released and separates any solvents, finally cutting up the granules with a liquid of hydrocarbon simply acting as a dilute. The mixture then passes under the pressure, which creates a slurry, hence the name. The product is then separated into the solvent. The evaporation occurs from the solvent, leaving behind the polymers, which have the catalyst. Finally, water vapor flows with nitrogen through the polymer to destroy the activity by reacting with the catalyst. The solution process, which has ethene and hydrogen under pressure in a solution of the Ziegler-Natta catalyst with a hydrocarbon. The polymer is obtained the same way as the slurry process. With LDPE, high-pressure methods are used at high capital cost. There are 2 types of processes for the synthesis of LDPE. LDPE is manufactured through the polymerization of ethylene at high temperatures in both of these processes. First, the tubular process begins with ethylene entering the system first, beginning with a pre-compressed, then being hypercompressed. Next, an initiator is used. However, different reactor systems use different types of initiators. Generally, the initiator is added multiple times in different sections during the tubular process. After each initiator has been added, there is a high pressure separator that usually separates oil, water, and gas from the previous initiator step. Next, a low pressure separator, which is used to separate the well stream, or the gaseous phase not separating from the liquid, into two separate components of gas and liquid. Finally, creating the polyethylene used to make LDPE. The popular process is more common than the autoclave process, which will be described later, because it is cheaper and less time consuming. However, only 57% of companies use the tubular process, while 41% use the autoclave process. Enters the primary component, where it is then hypercompressed. Next, it is pre-warmed and will enter the reactor, where they are exposed to high temperatures of steam and high pressures. After its journey through the reactor, it is exposed to PCV, positive crankside ventilation. This is the area in the engine that holds oil and is usually used to generate power. It then goes through a cooling phase and directly enters the HPPS, or high power pulse sputtering, which uses physical vapor in the position of thin films. Next, it goes through the LPPS, or low pressure plasma spray, which sprays plasma powder onto what was once the ethylene in the vacuum. Both these steps can be recycled through a cooling and separating process within multiple steps. HP will recycle after going through the hyper pressure, while LP must start from the beginning and go through the primary compressor before being recycled. After LPPS occurs, an extruder, or by using barriers and cylinders, is used by heating up the product and propelling it through the cylinders to create that desired shape. It is finally dried out and kept in a silo, or chamber till sold to consumers. As discussed in the previous slides, both HDPE and LDPE consists of long chains of carbon and hydrogen atoms. However, the difference between the two is that LDPE has branches that reduce its intermolecular forces. Polymerization must occur to synthesize both HDPE and LDPE. Both of these are usually used daily for many, whether it occurs on the cereal box to find the classic holding of cereal, which is LDPE, or using reusable plastic water bottles, such as HDPE. The reason these non-biodegradable products are so harmful to the environment is because they are changed from their organic matter through being synthesized and are unable to decompose naturally, taking hundreds of thousands of years for them to actually decompose. Though both HDPE and LDPE are recyclable, many throw these products away without a second thought. The lack of education in recycled goods is damaging the earth. Many millennials believe that cutting out plastic is the way to solve this issue. However, I believe that if there is a proper education of what and how these types of non-biodegradable products can be recycled, according to the World in Data, in 2015, only 19.5% of all global plastic was recycled properly, while 55% was discarded. In a more recent study, in 2018, that 19.5% reduced to 4.4%, while this number has increased from 0% in 1987, it has began to decrease significantly in more recent times. There is much work to be done. Schools can begin by teaching students how and what can be recycled properly from a young age for them to be conscious at that young age. New recycling protocol can be implemented in the workplace, as well as offering households the option to own a recycling bin.